Okay, in this video, we'll focus on part B of number 3. So hopefully here what we want to do is use the second derivative test, again, to show or provide evidence that this answer that I've given you, I've already given you the answer, the local minimum is this, the local maximum is this. Okay, so you just need to provide some type of evidence. Now, the nice thing is that in part A, you've already done all the work, so you don't have to redo the work. Excuse me. You already have this piece right here, which I'm just going to copy and paste. So you already have that. So, I mean, you don't even have to redo that. So that's, even though part A is long, at least part B, you already have a lot of work done. You already know the critical numbers, right? They're already done. You already know the outputs. So now it's just the second derivative test and the interpretation. So the second derivative, excuse me. So the second derivative is just f double prime of x equals 12x plus 6. And then if you remember the second derivative test, all you have to do is plug in the critical points. Or the possible turning points. This doesn't need to be here. Okay, so f double prime of negative. So let's do it like this. So we're going to plug in the critical points and interpret at the same time. That way, some of you are looking for something shorter, so this will give you something shorter. So f double prime of negative 4 is equal to 12 times negative 4 plus 6, which is equal to negative 42, which is negative. So by the second derivative test, f of negative 4, which is equal, by the second derivative, actually, let's do this. So some of you did something like this. So you negative, which I'd like, because this shows me you know what's going on. You take the second derivative, it was less than or equal to less than 0, and you said concave down. And then you just need hence or thus f of negative 4, which you already know the answer for. You didn't have to do, by the way, you didn't have to do all this work over here, but some of you did. But hence this f of negative 4 is a local max. So I know from your work that you understand that being negative is a local max. And then f double prime of 3, which is 12 times 3 plus 6, is equal to 42, which is greater than 0, which means concave up. Hence, f of 3, which is equal to negative 135, is a local min. That was really all that was needed on the second one. Find the second derivative, plug it in, tell me the concavity, and then reach the conclusion that we know. We already know the conclusion, but we just have to show me why it's true. Okay. All right. So I hope this helps. I'm not going to do number 4 because that's a good practice, and I've already given you the answers to number 4. I've already told you which was the local min, and I've already told you which was the local max. And I think for the most part on number 4, maybe what I'll start with the number 4 is how to, actually, let me start you off with number 4, because I think the only part that people struggle with number 4 was the following. So number 4, g of x is e to the x plus e to the negative x. I think finding the critical numbers was difficult for some of you. So g prime of x is e to the x minus e to the minus x. So that part most everybody knew. You all set it equal to 0. You all did something like this. And then here you weren't sure where to go to next, but remember the inverse of e is natural log. So you can plug in the e parts into the natural logs. And luckily the left becomes x, the right becomes negative x. Here, if you understand numbers, you can ask yourself which number is equal to its negative. That would be 0. But if you don't think of it that way, you can just add x to both sides and you get that x equals 0. So this is the critical number, which, I mean, you should have known anyway because I gave you the answer, right? So, so on these problems, when I tell you to use the first derivative test and the second derivative test, that you just have to, what really I'm going for is understanding what the symbols mean and the procedure, and especially for the first derivative test. Okay, that's it for this video. Thank you very much. I hope this helps you. And we'll do one more. We'll do a couple more.